Hello, it's Mr. Gridley with Kitchen Chemistry. Today we are going to try to understand isotopes and the average atomic mass on the periodic table. So in order to understand the average atomic mass, we have to understand there are different kinds of each element. There's not just one kind of carbon atom, there are different kinds of carbon atoms. Some weigh 12 and some weigh 14. The best way we're going to do this is to make an analogy. And the analogy is that we're going to try to use beams as different kinds of isotopes of the same element. Isotopes being the same element but different masses. So our goal today is to try to figure out what is the average mass of the beam in the bag. Now, averages are sort of easy, but yet they can be very difficult. If you look at this bean bag, okay, what is the average mass of a bean? Well, we have different kinds of beans. Some of them are large limas, those are the big white ones. Some of them are the kidneys, those are the red ones. And the small ones, those are the navies. So given three different kinds of beans, we don't know what the average is going to be because we have different heavy beans and light beans and medium weight beans. Not only that, but if we look at the bag itself, there sure are an awful lot of red beans, those kidney beans. So if we were to pick a random bean, we would probably end up picking a kidney bean. So what we're determining today is not a simple average, but what is called a weighted average. A weighted average is not the same thing as a simple average. So how are we going to do this? Number one, we are going to get the mass of each type of bean. Now, how are we going to do this? We're going to go ahead, open up our bag, and get a lima. Nope, here's our kidney, and then we'll get a large lima, and we'll get a kidney bean. Now, if we weighed just one of each one of these beans, okay, if we weighed just one kidney bean, we might have picked a kidney bean that's a little bit too light or too small. So rather than just simply getting one of them, we're often going to try to get a few of them. The lab might call for 5 of them. You might get as many as 10 of them. Okay, I've got 5 here. The lab actually calls to get 10. And I simply picked 5. It doesn't really matter, but you do want to get a couple of them so you can get a reasonably good estimate as for what the average mass of a kidney bean is. We turn the balance on, we weigh all of our beans, and 5 beans weigh 2.53 grams. You'll have to figure out what the average mass of the kidney bean is. So we'll record that information as the lima beans, our kidney beans, they are 2.53 grams for 5 of them. We're now going to go ahead and do the same thing with our small navies. I've got 5 small navies. You could get 6, you could get 10. It doesn't really matter how many you get, but you want to get a couple of them so you get a good representative sample. Again, those small ones, those are the navies. Maybe you've had some navy bean soup before. So I'm going to choose 5. Again, it's an arbitrary choice. How many I'm going to weigh. We get all these on there. And 5 of the navy beans weigh 1.02 grams. And finally, I'm going to go ahead and return these to our bag, and I'm going to get the limas. I'm going to get 5 limas as well. Again, you could get 5, you could get 10. I chose 5 because it's just simply quicker and easier than getting 10. And by getting 5, it's a pretty good representative sample of a lima bean. 5 lima beans are going to weigh 6.78 grams. So in order to figure out the mass of one of each one of these, I'm simply going to divide each one of them by 5. So we've weighed 5 limas, 5 kidneys, and 5 navies. You could weigh 10 of them. We'll simply do some quick math to calculate what the average mass of a lima and a kidney and a navy bean might be. These might be a little bit different, but we feel pretty confident by weighing as many as 5 that we have a good average mass of a lima, a kidney, and a navy bean. We now have to count the number of beans. Can we count the number of beans? Now, here's a question. Can you count beans without counting? So that's a tough question. Some people have an easier time, some people have a harder time figuring this out, but you don't want to sit here and count beans because it's just a waste of your time. There's a way to do it without counting. Can you count without counting? Well, our first step to do this is we're going to have to separate all the different kinds of beans. Here's our bean bag, and that's going to be our biggest job, is we have to physically separate all the different types of bean. So we'll have a container filled with kidneys, a container with limas, and a container with navies. So let's go ahead and do that now. Boy, this sure is taking an awful long time trying to separate all of these. One strategy if you're in lab is to take the bean bag, spread it out over a course of the entire lab station, and then move them around. Okay, have all 4 hands working, you and your partner moving them and separating them. You want to get the mass of a container before you go ahead and fill it up. So mass each one of the containers first and record it, and then you can go ahead and put them all in there. Now, what if there's so many of these red kidney beans that they don't fit in the container? Another question you might have, another problem you might run into. Let's go separate these and I'll be back. Well, we're not quite done yet. We're halfway through our bag. The problem is that our kidney beans are full and our lima beans are almost getting full. Our navies are good. We have some space there, but I've had people who say, I can't do any more. So you can do some more. Let's weigh these at this point and see where we are. We're at 151.16 grams. So 141.16 grams is where we are after we fill up this. Again, I want you to think about what will you do if the bag is full. Remember, okay, we could transfer it into a bigger container and then keep going. So that's a helpful idea. You might also come across some mutants, maybe a kidney bean got cut up or something like that. That's okay, we can go ahead and just throw those ones out if they're a little bit disfigured. But keep going. Again, you can see physical separation techniques are really important. We have a number of physical separation techniques: chromatography, distillation, centrifuge, separatory funnel, magnetism. Unfortunately, none of those are going to work for us today. And you can see how difficult and annoying it is to manually, physically separate all of these items. So keep going. Well, our bag is empty. We finally separated them all. And we can see we just have enough for our limas. So let's go weigh our lima beans. Again, this is the mass of the lima beans and the container. And they weigh 141.03, so 141.03 grams. I'm going to have to subtract the mass of the container, 14.73 grams, to get the mass of just the limas. Let's now go ahead and do the navies. So the navies didn't quite get filled up. The navies weigh 77.50 grams, but that's the mass of the navies and the container. The container weighed 14.68 grams. We'll subtract that. And finally, we almost filled up another entire container full of our kidney beans. So this weighs 94.99 grams minus our 14.78 grams for the container. So we have the limas minus a container. The kidneys, we had to do 2 containers, okay? We weighed them once with a container that was full, and then we did it again. Each time we're subtracting the mass of the container, and finally we have the mass of all those navies, minus the mass of the container. Once we have the mass of all of them and the mass of one of them, you should be able to figure out how many beans there are of each type.